All right, so next up, we're going to Iceland. And this is another kind of glacial outburst flood. This one, however, is going to be different in that this flooding is caused or was caused by a subglacial volcanic eruption. So it's not so much a lake outburst as it is just a outburst. I mean, maybe there were lakes forming on the top and underneath. And in fact, we're going to see a graphic here in a little bit that will show that. But it's a little bit different than the first situation. First off, let's talk about the name of this volcano, which is this right here. So this is Iceland. So this is Icelandic. Let's go through the pronunciation because you look at that word and it's like, whoa.
Eyjafjallajökull.
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 That's fast.
Eyjafjallajökull. Eyjafjallajökull.
Did you get that?
Eyjafjallajökull.
What does it sound like in English?
Eyjafjallajökull.
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 Eyjafjallajökull. I'm sure I'm massacring that, and I apologize to all my Icelandic brothers and sisters. So where is this volcano? Let's find out. If you're having a good time, make sure you hit subscribe, ring my bell, follow me on all the platforms. If you want to hear the ding ding of the Topo trolley. Okay, here we are. Let's go to Iceland. Oh, jeez. And this is it. This is the volcano that we are talking about. The situation here is you have an ice-capped volcano. This is in southern Iceland. There was a 2010 series of eruptions that became infamous for causing widespread disruption to air travel across Europe due to the massive ash cloud. Okay. And I remember this, 2010. So this was 16 years ago. If you were around in 2010, you probably remember this too, because it was in the news. And again, like this says right here, the main point was, we got to stop flights, I think, in Europe. And it basically just really disturbed air travel because of the ash. So there was an eruption in April, there was an eruption in May, and then there was a June, October eruption, a series of these eruptions happening. And there's some Icelandic houses there. You see these little white things? We have these here. Here in Pennsylvania, they're filled with hay, I think. The eruption's ash cloud led to the largest air traffic shutdown since World War II, from April 15th to 20. Over 300 European airports closed, canceling more than 100,000 flights and stranding about 10 million people, passengers. Airlines lost an estimated 1.7 billion in revenue. So that was the major impact. But we're going to watch videos of this thing, and I think what happened on the ground, right? Boots on the ground in Iceland is way more dramatic than the canceling of the flights. Of course, that was inconvenient. We're going to hit some video here in a second, okay? Interestingly, the eruption boosted Iceland's tourism in the long term, drawing attention to its dramatic landscape despite the initial chaos. And if we pull out here, you can see it's this one here. And you see there's a lot of these glaciers, a lot of volcanoes. There's a big one here too. But the one we're talking about right here is right there on the southern side of that very interesting island known as Iceland. So let's go to the video. This is the glacial flood, April 14th, 2010. The channel is HP Johns. And there it is. Yeah. Reykjavik, we have a problem. Whoa! Look at that. Seeing this? Here's the glacier, right? This is the mountain, right? The volcano's up there. And we'll look at the graphic in a second. This thing was spitting out huge amounts of this type of water from multiple spots along this volcano. This is one of them. Look at the scale, though. And this stuff is just filled with grit and boulders. You don't want to get anywhere near this type of water. Not only is it moving really fast, but it's filled with stuff that'll just rip the flesh from your bones. And here's another spot right here. And then as it moved down into the valley, there's a river there on the northern side of the volcano, I think, where most of this, the bulk of the water discharge, it's miles wide, right? that brown muddy water. It's the river is made to be miles wide. And it just went on, it all went into the ocean, right? And it destroyed stuff. I think it did a fair amount of damage to the local infrastructure. Again, just the scale. Oh, geez. Imagine yourself being like, you're standing here watching this happen. The sound, imagine this, the sound alone would be terrifying, right? Was that like a 500-foot waterfall? 1,000-foot waterfall? I mean, it never ends. Again, that was a video by H.P. Johns. So the northern outlet glacier of this ice cap, the big chunk of ice that sits on top of this volcano, is known for being the site of a massive, and let's look at that word right now. So this is the word in Icelandic.
Jökulhlaups.
Jökulhlaups.
Jökulhlaups. Jökulhlaups.
Jökulhlaups. And in English, it translates to
Glacial eruption.
Jökulhlaups.
which are catastrophic short-lived floods caused by subglacial volcanic heat or ice dam failures. In the 2010 eruption, it was caused by a subglacial lake to breach its dam. Okay, so there was a lake. I was right in the beginning there. The Suicide Basin one is a glacial lake that's next to, right, feeding into the main part of that glacier in Alaska. Glacial lake outburst flood. So that was a GLACIER. This is a GLACIER too, except in this case, the lake was underneath the ice. The eruption caused, so the volcano erupt. The heat of the eruption melts this stuff like that, creates a lake under the glacier, and then there's a dam that backs up the lake under the glacier, and then that dam fails. So yeah, it's a GLACIER. So why was it such a big deal? Why was it such an impactful event in terms of global airline travel, right? Well, because you don't want to fly a plane into a volcanic ash cloud. But why exactly? Well, let's find out. Volcanic ash causes catastrophic aircraft engine failure by melting at high temperatures, coating turbine blades and plugging cooling holes, which lead to flame-out surges and loss of thrust. The abrasive particles also sandblast exterior surface, damage sensors, and erode compressor blades, significantly shortening the lifespan of your engine. Ash particles melt in the combustion chamber and fuse onto high-pressure turbine blades and guide vanes, disrupting airflow. This is what's happening inside the engine of a big jet airliner. Rapid accumulation of melted ash can cause total loss of thrust, as seen in the 1982 British Airways Flight 009 incident. I don't know anything about that. That might be something you guys might want to look up, maybe leave a link in the comments here. I think that's an event that maybe had to do with a plane flying through ash. Ash clogs fuel nozzles, cooling passages, and pitot tubes, I'm not sure what that is, leading to inaccurate readings and overheating. Windshields become opaque, and the airframe is damaged by sandblasting. So essentially, if you're flying into an ash cloud, it's not just super like fine little pieces of it's like little pieces of glass, right? Some big, some small, but you're flying into a hot gas cloud. If you're in a big jet, you're going, 400 or 500 miles an hour? The windows of the plane sandblasted, like frosted, like that frosted effect. So you wouldn't be able to see out of the windows. And basically you would go down. And that's why you don't want to fly into a ash cloud. And here's an animation that's going to show you what the ash cloud looked like. Here's this little thing there, that's Iceland, and that green stuff is the ash cloud over time, kind of wafting over to Europe, and then this arm is kind of coming down here into Canada, Nova Scotia, and then boom, right there, Western Europe is completely covered with this ash. It just swamped the whole thing. So it wasn't just, we can't fly a plane up here close to Iceland. It was, we can't fly planes anywhere in this area. This is a very popular route, right? Because everybody going to Europe, going to the US is going right over there, right? They don't go like this. They go there because it's shorter, right? Everybody going that way, boom. So it was a big, big disruption. And that was in the news. And I do remember that. Do you remember that? If so, leave it in the comments. This next video is by Martin Reitze from 6 years ago. This is time-lapse footage of the eruption. We're going to speed it up here. Remember, when you're looking at this, these clouds of ash. Look at that. You see that stuff it's spitting up there? I think that's called scoria. Huge chunks. How big is this chunk right here? This chunk could be as big as this room, right? And it's just flying through the air. You know, when you speed it up, it really kind of makes it a little bit more dramatic because you see everything unfolding just much faster. Huge chunks. And this stuff is hot. Whoa, what was that? Watch. Did that almost look like, you know, when a plane, you ever seen the pictures of jet fighters when they break the sound barrier, I think it is, and sometimes they get that weird cone in front of them. I don't even know what that is, or if that's actually what's happening here, but that's kind of what that looks like, right? Because we're speeding this up, but look how fast it goes. You see that? What was that? It's beautiful in a way. It's like the ultimate fireworks. And some of these pieces are red hot. Those are the red hot pieces. It's just the earth just belching out stuff that is actually underneath the earth, right? Whoa! Yeah. Just total destruction. What's that over there? You see that? Look how high those things are getting shot up in the air like that. So this is what's causing the ice to melt. And you see this and you're like, oh, okay, now I know why there's so much water pumping out of this glacier. Again, that was a video by Martin Rietza of the 2010 eruption. And what we were seeing there was volcanic ejecta, and that refers to any material, ash, rock fragments, pumice, or lava bombs explosively expelled from a volcano during an eruption, right? That's all that stuff, ranging in size from fine dust to massive blocks. This material travels through the air very fast, as we're about to see in the next video, often forming a tephra blanket. When falling as large projectiles, ballistic ejecta. So those big things, that was ballistic ejecta, what they call ballistic ejecta. And you can break this stuff down by size, millimeters here, dust, ash, lapilli, right? And they get a little bit bigger. Then you got blocks and bombs. Volcanic ejecta can cause significant hazards. Roof collapse, right? Gets so heavy the roof collapses. Ash loading, respiratory issues. You breathe this stuff in, guess what happens? The ash, which is like glass, little sharp pieces of glass, you breathe that in, basically turns into cement. And it's like you're having your lungs filled with concrete. That's a horrible, horrible way to die. You know what I mean? Ejecta can travel vast distances, altering landscapes, affecting climate, and influencing soil chemistry. Ballistic ejecta, large, fast-moving class pieces of rock, typically 15 to 20 centimeters in diameter, thrown from the vent, capable of causing lethal injuries within a range of 5 kilometers. Right? So 3 miles. You're 3 miles away, looking at the ash cloud, and then all of a sudden, here comes some ballistic ejecta. Boom! Lava bombs, molten or semi-solid material that shapes itself while flying through the air. And that's the red hot ones that we saw. Those were, in fact, lava bombs. And this next video is a real eye-opener in terms of that ejecta. It's a video by Volcane Chris. This is the 2010 eruption. And there's a plane, looks like a prop plane, flying around this thing. Now, what are they doing up there? They're obviously avoiding the ash, but they're probably up there taking pictures, taking measurements, doing science, or maybe emergency work, you know, trying to figure out where this thing's going, how fast it's going, telling these people down there on the ground, you got to get the, you know what, out. Props to these people flying around. This part of the video, this is a vast plain of dark volcanic soil. Peeking over the top, right, this horizon line here, you can see the plumes of ash. Note, and this is a person right here. That thing there, that's a person. That might be Vulcan Chris. And these spots up here, that's that volcanic ballistic ejecta. And we're going up there. So they're hiking towards this thing. What a shot that is, huh? And then there it is. You see it? The scoria, the ejecta. Ooh, where it comes. Some of these chunks are huge. This is what you're seeing. This is what this person is seeing. They're walking up towards this. And this video is slowed down, right? This is slow motion. Oh, there it is right there. You see that? That's a lava bomb. You can actually see this has still got some major heat. Although, you know, a piece that looks black, right? It's still going to be hot enough to just burn you, right? Obviously, probably burn you to death. So if they're coming up out and they're flying through the air and they're still red hot, like molten, then you know then you know they're very, very hot. Here's another shot of the person in the red jacket. How far are they? They could be a mile or two away from where this is happening. And yet still, they could easily get hit by this stuff. Like I said, that's Vulcan Chris. That's from 15 years ago. And that is the eruption at the crater in Iceland. So go check out that channel. This next clip is by Robert Beck. It's from 15 years ago. This is the Iceland volcano. Huge rocks falling from the sky. Crazy tourists. You look on this little ridge here. You see these incoming bombs? You see these incoming pieces, chunks of rock? Now, the title is saying that these people are tourists. I don't know if that's true. They look like they're taking pictures, so they're probably, you know, photographers and whatnot. And they're up on this little ridge. There. Incoming. You see these, boom, and they're coming close, too. That one hit there. Now, it might have been down over the edge there, but if you're standing at this place and you're taking pictures, and you've got these ballistic ejecta, pieces of ballistic ejecta coming at you, the size of a truck, coming at you. There's one there. You see it? And this footage is from a plane. So you're in a plane and you're dodging this ejecta stuff, right? How do you know exactly how close you can get, right? Because you can't predict every single blast is going to be, you know, the same or less powerful than the previous one. So you're flying, get close to get good footage or whatever you're doing. How do you know the next one's not going to be 10 times as powerful, right? You don't. That was Robert Beck. Crazy tourists. Vid showing scoria bombs. Scoria, where is scoria? Hold on. Scoria is a vesicular, dark-colored red, brown, black volcanic rock, often called lava rock or cinder, right? Formed from cooled, gas-rich basaltic lava. It's lightweight, rough, and porous, commonly used for landscaping, drainage, lightweight concrete, and barbecue briquettes. It is primarily found near cinder cones worldwide. So I don't know if they would say that's scoria shooting out there. Maybe it's just ejecta, but a lot of it might wind up as this scoria stuff. Am I saying that right?
Scoria.
Scoria. It's a cool word.
Scoria.
So this is a graphic from a paper, a scientific paper about these eruptions. And why I am showing you this is because it gives you a good view of what's going on here. Here's the volcano, right? Ice cauldrons, craters. The ice cauldrons are basically cauldrons of ice that melt and become lakes, subglacial lakes, right? This purple is lava flow, right? So that's where the actual lava came out and laid on the ground there. And the Jökulhlaup path, right? The dark blue line is the glacial outburst flood. All right. So you can see some went this way. Two of them came down this way, right? Now this lighter blue line is the glacial margin. Okay. See how it's like going like that. So that's the edge of the glacier. So the water is coming from here, forming subglacial lakes, which are then bursting their dams. It's all happening underneath, right? And then they're flowing out, way out to the edge of the glacier where they would then squirt out of this glacier. And we got a cool clip coming up that's going to show you, I don't know if it's the same location, but it shows you a very interesting example of water popping up out of the glacier. And this is a profile. One of the outlets is this way. Another outlet is this way, right? And this is the summit caldera. And you have two big cauldrons, water, okay? Active conduits. So this is magma surging up from below. And this is the light gray line is the path of the Jökulhlaup. Huge amounts of glacial ice melting very rapidly and then flowing beneath the glaciers to multiple exit points on the sides of this Icelandic volcano. I wanted to show you this because it had some interesting facts in here. Q&A, what happens when a volcano beneath a glacier erupts? Okay, this is from a website. This is like a government website, NSF. Let's just see what I have highlighted here. Question, does ice under lava create special hazards for people living downstream? Explosive glacio-volcanic eruptions usually produce the most rapid ice melting, right? You can have ice melting from heat from in the atmosphere, but the big ones are usually going to, the most rapid melting is going to be caused by volcanoes beneath glaciers. Theoretically, lava can melt about 5 to 10 times its own volume of ice. If all the heat from the lava, which could be as hot as 1200 degrees Celsius or 2200 degrees Fahrenheit, wicked hot, melts the ice. So lava can melt about 5 to 10 times its own volume of ice from the heat. Question, is there anywhere else on Earth such glacier volcanoes exist and have erupted or might in the near future? And here's the takeaway right here. Our work show that at least 180 volcanoes around the globe have glaciers that have been mapped to within 1 kilometer, 2/3 of a mile, of a known volcanic vent. So 180 volcanoes that come within 1 kilometer, less than a mile. They come very close to these volcanic vents. More than 400 may be within striking distance as a 5-kilometer radius of damage from volcanic ash or lava flows. So basically 180 volcanoes around the world where you have volcanic vents situated very close to large masses of ice, which could lead to these GLACIERs. So let's wrap up this video with a few bonus material items here. This one is by Play Now, Work Later. That's the name of the channel. It's a short called Water Bursts Through a Glacial Crack. Here we have the end of the glacier, or the toe. Is it called the toe of the glacier? The foot of the glacier. And you can see the ice rapidly rising up in the distance. This looks like it's shot from maybe a helicopter or a plane. And in this case, it's just bubbling or surging up through a crack. This looks like a crack or crevasse, right? So underneath here, on the upslope here, you have hidden subglacial conduits, right, that are pumping out this brown water, right, because the bottom of the glacier is resting on the surface. So you're going to have boulders, sediment, all that stuff. And you're going to have water surging along that, right, carving out the cave and also bringing all this stuff with it. And it just erupts from the foot of the glacier, and it looks like that. Now, I don't know what the scale here is. You can see a little entrance here. So, I mean, I'd probably safe to say this is at least a couple hundred feet from this spot here at the very end of the glacier to this plume of dirty, muddy water that's just erupting out of the glacier. Let's watch this again. And sometimes it happens like that, right? It doesn't flow over, doesn't come under. It actually pops up the top. And the pressure must just be insane, right? Because who knows how high up the valley you have to go to the spot where this stuff is originating, right? So the hydraulic head pushes it up. It could be pushing this brown muddy water up through a 300-foot vertical shaft going up to the top. Again, play now, work later. Water bursts through a glacial crack. This, along with everything else, will be in the description as always. Next up, we have another video by Pilot Lee. I think I already featured one of those. And again, this is Alaska. And she's flying around, checking this stuff out. 8 hours later, it was draining. Okay. Notice at the edge of the lake, the level is beginning to lower. Okay. So they're looking down here. This is the lake. Is this the one in Juneau? I don't know. It might not be. It's the same basic concept. And this video is really neat because it shows what happens at, what it looks like after it's drained. You got the blue ice, right? You got that grayish, just freezing cold water. Look at that. That's what it looks like when this thing drains. Here's the main part of the glacier, I think. So the water, I think, would be going this way, and it drains fairly rapidly. The Mendel the Mendelhell, or the one that comes out of the Suicide Basin, that took, what, 2 or 3 days to drain. I think they said this took 8 hours. And again, they're high up in the air. So these blocks of ice are just the size of cars and houses. It takes just 24 hours to completely drain, leaving behind freshly exposed glacier ice. And again, this is Heli Pilot Lee, the most spectacular, mind-blowing event you will ever see. They come in close here. Gotta love the color of that ice, contrasted with the sediment, the dirty sediment there. Historically, this event happens once a year here, so maybe this is the Juno one. Look at that, how blue that stuff is. And I've witnessed it in action only twice. Maybe this is the Columbia Glacier in the 17 years I've been doing this. So she's been doing this for a long time. And this is only the second time they've been able, look at that they've been able to film it. And the ice, most blue this ice will ever be. It's a kind of a post-apocalyptic thing going on here, right? I mean, thank God a lot of these glacial stuff happens in parts of the world where there aren't a lot of people. I mean, that color is insane. And that tower of ice there, what is that, like a 200 foot tall tower? All right, so that was, again, Heli Pilot Lee. So go check out her channel. She's flying around there making these amazing videos. Now, this is showing another volcano in Iceland, Grímsvötn, I think it's called. I don't know, maybe that's the name of the glacier. But I wanted to show you this because this will give you an idea of how far the water, how far the glacial lake outburst floods can travel beneath the glacier. In Juno, it looks like it's coming down, several miles, right, from the Suicide Basin. But this was an eruption and flood that happened in Iceland. If you look closely, you can see the island is outlined there, and the red square, the red rectangle is where we're zoomed in. I think the other one we were just looking at was right there. So I think this is where the eruption happened, right here. And those dotted lines, right, represent the subglacial flow, and then it pops out here at the foot of the glacier. I guess that's the name of the glacier. And the black line represents how it's going out into the ocean. But if you look at the scale here, 10 kilometers, right? So that's about 6 miles right there. So from the exit point to this arrow here, it's going to be about 5 or 6 miles. So if we go up here, 1, 2, 3, 4, 5. We're looking at a subglacial conduit carrying the water from this subglacial eruption 20 to 25 miles long from here to there. Like, what the heck is going on underneath there, right? How thick is this ice? What would it be like to actually get into that thing? And how could you even do that? Because that's a long distance, 20 miles. 20 miles of ice caves flowing downhill, off of the mountain, off of the glacier. That's crazy, right? My first thought was swamp boats, right? Swamp boats or airboats are flat-bottom, propeller-driven vessels designed for shallow, vegetation-heavy wetlands. So they're not really designed for that. But since the water in these ice caves, glacial ice caves, the water at the bottom of the passage is going to be, it's not going to be even, right? So it could be 6, it could be a foot, it could be 3. So I was thinking, if you could basically take one of these swamp boats or an airboat, these things can go in very shallow water, right? And you'd have to almost design one specifically for this application, right? You have to have extra thick hull, stuff like that. And I don't even know if this is going to be the right thing to do. But that was the first thing that popped into my head. Send swamp boats, airboats up these things and see how far you can get, right? And you could do it for science, right? You can go out there, collect data. And then I thought, you know what? Even better, what if you were to send one of these amphibious off-roaders, right? One of these suckers, right? Because it's It's called a fat truck. This is what you would need, right? Assuming that the conduit is big enough to drive one of these things up, because these vehicles, which we did feature in a previous video, I forget which one. Oh, it was the flooding. We did a video on flooding, recent flooding in Mozambique. Go check that video out. They use these things to go out and rescue people in isolated areas for flooding, because the tires, they have these cool wonky tires that can actually serve as propellers in a way, in that you can go through water that's deeper than the tires. You can float and paddle wheel your way basically across lakes in this thing. And then if it gets shallow again, these tires are designed so that you can then just cruise along the bottom of a stream bed or a riverbed on these incredible tires, right? And you can put stuff in there and you can rescue people. Why couldn't you take one of these, right? Trick it out, customize it for the application of driving into a glacier, driving through these subglacial cave passages, right? Ice cave passages. You trick it out with lights. You got all the sensors, right? You got people in there driving, right? And then you think, yeah, but how crazy is that? That's kind of crazy. It'd be wicked dangerous, because the glacial caves are not like caves going through rock that are a lot more stable. These things are they're shifting, they're cracking, they're collapsing. It pretty much would be a death sentence, right? So my next thought was, well, hey, why don't you build something like this, maybe on a smaller scale, and trick it out with everything that you need, but have it be an ROV, a remotely operated vehicle, right? So you could control it, where it's going, what it's doing from the entrance, right? From where this stuff is coming out of the glacier, and you send this thing up in there so that if something happens to it, there's no loss of human life, but you could still collect the data and the video, the temperature, right? You could do maybe thermal imaging, and maybe even on the top of this thing, you could have, drones, like maybe you could have 4 probing drones that, let's say you get to an area where, as good as this thing is, it can't go any farther for some reason, right? But you have enough airspace, because these conduits, you got that much water coming through. Some of them, they have to be, 50, 100, hundreds of feet. These have to be, some places, these things are going to be huge, right? So let's say you can't go any farther with that, right? Okay, what do you do then? Boom, you start deploying these probe drones, right? We send these off up into the conduit. And or you call them suicide drones, because they're probably not going to come back. So you just say, okay, deploy the drones. We're going in, and you send these things just as far back as they can go, right? And they're sending back the data. I don't even know how that would work. I'm pretty sure they could do that, though, right? They're sending back the data as they go along, and you just push it as far as you can go. Maybe you can make it a mile, 2 miles, maybe not even that far. I don't know. It's a crazy idea, but because these things are so long, 20, 25 miles, it would be worth it to go up there and see what's going on and do some science up there, right? Because then you would be able to understand what's going on better, right? And that's the whole point, to better understand it. Or maybe something like that. I don't know. That's a little bit too much. But yeah, look at these things. I think there's various companies that make these things, and this is what they do in the water. Here's one. They just go over a frozen lake. Look at this. It's capable of doing that. It can go across ice. It can go across water. It can go across land. Now, it's not that fast, but you could go places with these, and maybe, like I said, make smaller ones, right? Make little ROV versions. So that's going to wrap it up for this episode. Like, subscribe, all that good stuff. I hope you had a good time. I hope you learned something, and maybe even were entertained a little bit. Got to watch out for these GLACIERs. They are the real deal when it comes to devastating glacial phenomenon, right? This is Brett for Topo Ranger, and I'll see everyone in the next episode.